Hi guys, this is Steve Darcey with GoEngineer, and today I'm excited to benchmark the new APEXX S3 from BOXX and the new Dell Precision 7920. Now, these are both of the machines that are highly recommended for SOLIDWORKS, so that's what we're going to be documenting and doing the benchmarks on. Now, the Dell is a lot bigger machine, but we'll see which one is better. All right, so one of the first things we need to take a look at, of course, is large assembly open time. This is what customers spend a lot of time doing. So I'm going to open these guys up at the same time. Again, the APEXX S3 is on the left and the Dell Precision is on the right. So I'm going to try and hit these at the same time. I'm going to go ahead and also do these fully resolved so you guys don't think I'm doing anything crazy. And it is the exact same assembly. So here we go, 3, 2, 1. We can already see that the box is starting to open up a little bit quicker, even though the timeline on both of these is about the same. You can see this dialog pops up. We'll wait for it over here on the Dell. I'll hit it at the same time. There we go. And there may be a couple other things. You know, not all assemblies are perfect, so there may be some issues, warnings, errors, things like that that we have to click through. Right now our assembly size is 4,927 components, so we're cranking them right up. So here we go. Some of the things have changed. I'm going to go and rebuild. And we're getting pretty close. It's just about done. So we're about 3 minutes, 45 seconds. Close out of that. And we are fully open, fully resolved. 5,200 piece assembly, actually. So while we're waiting on the Dell, let's go into the evaluate. There we go, the Dell is now finishing 4 minutes. Again, we'll have a rebuild. Look at the performance evaluation over here. So about 4 minutes, 13 seconds to open. It's still working. So it should get a full time right here. There we go. And now we're fully open. So let's take a quick look at the performance evaluation of all these things. And we'll take a look at the top open times on some of the parts. You can see it's the exact same part. About 2.34 seconds on this component. That's the longest one. And over here we have 1 minute 58, or I'm sorry, 1.58 seconds. These are in seconds. And so you can see the time difference on most of these things. So we scroll on down is considerably longer just on open time. Now, open time has a lot to do with reading from the hard drive, going through the CPU, and then putting it into memory. So that's a lot of what we're doing here. So I've gone ahead and closed the assembly. We're going to look at the open time again. And this time I'm going to do it in large assembly mode. So if you guys are familiar with that, it's a little truncated mode. It doesn't load everything fully resolved. So I'm going to start this guy up. Ready, go. And we'll take a look at the splash screen. 2018 actually shows you with the last time this was open, fully resolved, it was 6 minutes, 53 seconds. If we take a look over here at the Dell, the full time to open was 8 minutes, 45 seconds. So almost a full 2 minutes of time you could actually spend working. We're going to take a look at the 2D drawings. So I have a drawing that's already ready. So we're going to open that guy up at the same time. Here we go, click. And we don't have the little 2018 browser thing that pops up that tells us our open times. So we're going to do a couple things. I'm going to put the little swirlies out here so you can see the swirlies. And then we're also going to look at when this sheet refreshes, you'll start to see the browser tree start to propagate. So there we go. On the APEXX S3, we've already got our browser tree, but we still have the swirly, so we're not done generating the graphics or anything. There we go. I think the S3 has done it. We are completely open and ready to go. We can already go ahead and start working. We can look at the performance evaluation. We can see that the bill of material took a little bit of time or 10 seconds, 1 second for sheet 2, and the display graphics took 14 seconds to rebuild. We're still waiting on the swirly over here on the Dell. We're done now, so we can finally get to work. On the evaluate tab here, kind of same thing. It took 14 seconds for sheet 1, almost 2 seconds for sheet 2, and then the display graphics time took 22 seconds on this one. Now the interesting thing about that, I'm going to pull up our computer management and device manager, and you'll see under our display adapters we are using the same Quadro P4000, and they are using the same driver version as well, one recommended by SOLIDWORKS. So that is kind of an interesting thing, is that the graphics display time may have more to do with the speed of the processor than the actual graphics, but that's time to get your job done. We're going to do some flow analysis. This really kind of stresses out the CPUs and sees what we can do with each of the systems. A little bit of the setup. This is SOLIDWORKS Flow running right inside SOLIDWORKS. We have some different materials: copper, silicone, gold. It's a little PC board with ICs and components, capacitors, and things like that. We have environmental pressure coming out, and we have an inlet fan coming in. So we're blowing in cool air. It's going to just air cool this thing and then go out the outlets. I do have some heat sources. So some of these things are generating, on this guy is 2 watts. This guy down here is half a watt. We know some temperatures of some of the capacitors, so we put those on there. And then the IC itself has a fan or a cooling fin on it, and it's generating 3 watts of heat. So let's go ahead and run these things and we'll see what we get. So I'm going to run these both at the same time. Again, we have the S3 over on the left. Go ahead and get that set up. And we're going to remesh. That way we're starting from scratch. It's going to create a whole new solution. We're using all cores. So here we go. 3, 2, 1. And we're going to also bring up, again, the task manager, so we can see what task usage we're using on the CPUs. So one other thing to kind of notice here, Microsoft kind of changed the way they do this. You can say this guy looked like he's running at 3.7 gigahertz. This guy looked like he's at 4. This is just kind of the text title of what's on there. We need to look down here at the speed and the utilization of how good are we actually using that CPU and the cores. Notice we're right at 4.7 gigahertz, and over here we're at 4.3 gigahertz. So even though it looks like we have a faster core over here on the left, we're actually getting higher speed utilization. And it looks like we're done over here on the left. Solver's finished. Pretty much done with that guy. So since this one's still got a couple iterations to go, let's take a look at some of the cool stuff we could do. So let me go to the results file. We can turn on some of the flow trajectories. So we can kind of see where the flow's coming in. It's nice and cool. This is a temperature chart. And so as they go around some of the components, you see the colors starting to change. And they get a little bit hotter, and then should get pretty hot as they go out. We can also turn on another flow trajectory. So you can see a couple more of those. And then we can also look at maybe a cut plot. And I've turned on these little guys right here, and they're going to be rendered as I zoom in and out. They're rendered real time on the GPU. And when I animate that, because kind of what we're doing is we're making the 3D slicing it on a 2D plane and trying to show you what the curves actually look like. So you can actually kind of see the 2D curves, even though they may be actually swirling in the 3D sense of that. You can see those things kind of rendering real time on the GPU. That's pretty cool stuff. All right, so finally, yep, this guy is finished. It looks like he finally finished about 4 minutes, 10 seconds. The other one was, I think, about a little over 3 minutes, 3 minutes, 2 seconds, something like that. So pretty much saved a minute out of my day, a little over a minute. Let's talk about something that engineers do a lot, and that's rebooting. So I'm going to not save any of this, and let's just take a look at how these things reboot. So I'm going to do a restart, and here we go, 3, 2, 1. So we got a good reboot. We'll see which one starts up. It looked like Microsoft had a little update, but I went ahead and suppressed that. So it looks like the Dell actually shut down a little quicker. We're getting a little bit of signal back from the APEXX S3. And it looks like we're logged into the box. It's up and going. In fact, I can start getting to work. Let's go ahead and start up SOLIDWORKS. And maybe we can open up an assembly that we opened up on a previous version. Still waiting on the Dell to boot up. And if you haven't seen some of our other videos, this was a video we did with some flow analysis when we actually did a benchmark between the old BOXX APEXX 2, it was a 2403 model, versus the new S3 that we're doing here against the Dell. So you can kind of tell that if you want productivity and you have to reboot 2 or 3 times a day, or even if IT reboots your machine, you may be waiting a while. Maybe waiting a long while. All right, looks like the Dell is up. We can log in. And now we can go ahead and get to work and start our SOLIDWORKS. So you can see some big time savings in just every time you have to reboot.